So this is the same question, an example that I want to continue with. This is pima maths 142, lesson number 1.3. So continuing with the example number 6, and remember, suppose you are tiling a 10 by 10 floor. So that this is 10 by 10 feet. So if this is 10 feet and you want to increase it to 20 foot, okay, so the question is, and find that there are 100 tiles. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be 100 tiles. Okay. Now the question is, if you increase this to 20 feet, so that means this will be 20 feet by 20 feet. The question is, how many tiles will be needed to tile the floor of 20 by 20? Based on our proportion, it looks like, so as I said again, I repeat it, it looks like if it is 10 feet, so if this is the 10 feet, if the length is 10 feet, so I'm comparing the length and the number of tiles, length and number of tiles. So that will be, number of tiles is 100, so 100 tiles here equals, and if the length is increased by 20 feet, question is how much is the number of tiles. We want to know how many are these. Now if you do this way, this is as good as writing 100 over 10 equals x over 20, multiplying both sides. So if we multiply 20 both sides, and you can clearly see that this 20 crosses out and you get 2000 divided by 10, and we can divide 2000 by 10 and you get 200. Looks like 200 tiles. Okay, but if you see this itself is 100 tiles, and you can see this piece which is 100 tiles, we can break this, divide this into 100, 100, 100, 100, so it becomes 400 tiles. So if you see this, and not 200, so this proportion does not help. So if this proportion does not help, then how do we do is, what is the right one is, if this is a 10 foot by 10 foot, and the other one is 20 by 20 by 20. So we'll have to use the area. So that means if this area is 100 square feet, okay, if this area, so we'll do the area and the number of tiles. So this is the ratio we will have to take. So that means we can set up the proportion as, so area of the first one, when it is 10 foot, we saw the area is 100 feet square, and the number of tiles is 100 100 tiles. So if the area is, if this area is 100 feet square, so the 100 feet square, then the number of tiles, then this equals the area. This area is, you can see this is 20 by 20. What is the area here? This whole area will be 20 by 20. Will give you 200. Sorry, 400. So that will be 400 feet square. And we need to know what is the X number of tiles. So we don't know, let's say we don't know how many tiles are there. So that's how the setup is, which is 100 divided by 100 equals X over 400. And this is 100 is 1. So 1 is X over 400, and multiplying both sides by 400. So this crosses out and you get X equal. So X represents the number of tiles. So X number of tiles when the length is increased by 20. So this is how you get the answer. So there could be, so this could be the reason is to show is there could be an error in getting the answer. So you have to be careful. Proportion does not always help. Using the same length is increased. This also no. So it's the same thing. I can see if a circle is there with radius some 4 here, and the area here, let's see, is made double 8. So that doesn't mean the area doubles. So the area goes square of whatever this. It's the so if it is pi r square, then the new area will be pi 2r. So it means it becomes uh, pi times 4r square, which is 4 pi r square. That means it is 4 times the original area, whatever that is. So this is how you need to be careful. Okay, let's go to the next question. Suppose suppose this is a 7 example. A company spends $1,000 on an advertising campaign and gains 100 new customers because of this expense. So it's like you kind of very quickly think of a ratio of spending money like $1,000. So if you spend $1,000, uh, you end up getting 100 new customers. So this is 100 new customers. Okay. Does that mean by spending 10,000? So that means if you put 10,000, so what will be the X? So this is how the setup is done by taking the ratio of dollars and the number of new customer. So the question is the new customer really proportional to the money spent? Now, if you work this out, it looks like this is 100 over 1,000 equals X over 1 10,000 here. So multiplying 10,000 both sides. Okay. So you will see these two zeros and this two zero cross out. So the Indian shortcut. And then this zero and this zero goes out. So what are you left with is 1,000 customers. So it looks like if you spend uh, $10,000, kind of you're getting this answer $1,000. But in reality, let's see, this is a city or a town. In a town, let's see, because you advertise you spend $1,000 and maybe you got 20. These are 20 new customer. But just because you are spending $10,000, so does it means you'll get 1,000 customers? Let's see, you're buying a refrigerator like this. This is a refrigerator which is costing uh, quite a lot of money. But the question is, does will so the additional advertising will be less. So the question is, how many customers should they expect? Now, just because you this 10,000, this will not let you to get 1,000 additional customers because there will be only a fixed number of people in this town, who will be interested in buying the maybe the refrigerator or the hot tub like this. Okay, uh, so the few people. So there might not even be this 1,000 customers to buy this maybe hot tub or maybe the refrigerator, which may be very expensive. So it does not go proportionately. So this is like an error. That's what I'm saying. Is there is an error in some problems where you have to be very careful. So only because you spend $10,000, that will not be effective to get this X 1,000 customers. So that's how you have to explain that it is not effective. Okay, look at this question is about similar triangles, and by looking at it, you already know. Let me put some colors to show that means this is the length A. So these are so whenever the two triangles are similar, and what is the meaning of two triangles similar means this angle. Let's say this angle and this angle is the same. If it is 40, this is also like a 40, and if this angle is maybe 80, and this also becomes the 80, and if this angle becomes 60, and this angle 60. So the two triangles are similar. Not only that, you can see the sides are proportional. It means, let's imagine if this side is 8, this side will be 4. If this side is 12, this side is 6. If this side is 16, and this will be 8. So so the sides are proportional whenever the ratios if the two triangles are similar, the sides are proportional. So that means the new, and this is the old triangle. So what's happening is the 6 divides. So I can say this 4 divided by this 8 is same as equal this green, let's say this new side, which is 6, and this is the old one, which is 12, is same as the blue color. Let's see this one, which is 8. So 8 divided by this one, which is 16. And you'll see in each cases you get one half, and one half. And it looks like the first triangle is shrinks. So this also we can say that it shrinks by a scale factor of, so this is also called a scale factor of half. So it is a scaling, but it is shrinking. But you can also say, use another way, the ratio also. You could also use the other way also. So instead of new over old, you could go backward also. It means you could say from instead of saying x over a, x over a equals, oh here they already gave us this. So a over x, they start with, you can also take this divide by this. See? So it is a over x, that's the red color. And then you have the purple color, this over this one. So that's this b over y. And then this one, c over this one. So c over z. So these are called, this means sides are proportional. So let's see, take example, how do we use? So this is the definition for similar triangle. Uh, if if the two triangles are similar, so whenever two triangle, let's say A, B, C, is the symbol used is this squiggly thing, which is means similar, is to X, Y, and Z. So then we say, hey, two triangles are similar if corresponding angles are equal, that I already shown you, and sides are proportional. So we'll use this whatever that. You could also say x over a equals y over b. This also called this, and this is the same thing. Let's take directly the example. So this is example number 8. By look at it, you know it's given to you. You have to be told that triangle ABC is similar to triangle X, Y, and Z. So, and I wanted to look at the nice one. They gave this part, and this part is given to you. So that's the main thing. So I'll start it with uh, that piece. So the one that gave is let's see, AB over XY. So this is the one first part. So there are two parts here. Or you can also say AB over XY equals, so because this is a known one from a over 3, that means it's going to be 4 over 3. This is going to be 4 over 3. But then we'll try to take the other side and say, okay, let's write purple color, this one. This one will be this one. So that means we can say this equals BC. So this is BC over YZ. See, YZ, YZ. And the other one, you can take a green color to show. that this one and this one. It means AC divided by X. So I'm putting these colors to make sense. Now we'll write the whatever they gave us. This BC is given. So this BC is A, which we don't know. It's A. So let's put A. And this one, YZ is 4.5. So that is 4.5. And likewise, on the other side, AC is this piece, which is 3.2, the green color, and X3 is Y. So I try to take two ratios separately, say this one and this one, and work on it. And you already worked this. Okay, you multiply. So here, multiply 4.5, and you multiply and multiply 4.5. So this 4.5 crosses and you get, so you get A equals 4.5 times 4 divided by 3. And you can clearly see 3 divides 4.5, which will go 1.3. And then you get A equal, you can do your own calculation also. And when you multiply 1.3, so 4 times 3 is 12, 1 carry, and 4 times 4 is 5.2. I think I made a mistake. This should be, so this should be 1.5, and 1.5 times 4, you get A equals 6. Okay. Or you could also do another way, is just multiply here. A equals, you could multiply 4.5, that will give you 18. That will be, if you check, it will be 18, and then divide by 3, you get 6 also. Now this problem, let's finish it here. So use cross product. So multiply these two, that will be 4 times y, and then you multiply this one, which will be 3 times 3.2. So that, and then divide by 4. So, and divide by 4. So this crosses out, and y equals, and you can see this 4 that you see at the bottom. So this 4 goes, 4 does not divide 3, so put 0, but 4 divides 32 8 times. And when you multiply this 3 times 0.8, you end up getting 3 times 8 is 24. There's a 1 place decimal, so you go back and put a dot here. So, or you can use your calculator also and figure that out, the answer, because not always will be given. So this helps how to do this type of problem. So next, this is example number 9. You are curious how tall is the, so you want to know how tall is the tree. We are standing next to the tree and you want to know, okay, you are curious how tall is the tree but don't have any way to climb. Suppose the tree is casting a shadow that is 15 feet long. So this is a very important information, 15 feet long. That means, let's see, I can draw, let's see, this is a tree, this is a tree, and we don't know how big is this tree. And then it cast a shadow of 15 feet. So this is 15 feet, and we don't know what is the height. So I'll call this as the h is the height of the tree, but there is another person next to it who is just 6 feet tall. So there is a person here, and he cast a shadow of 1 feet. So that means this one. So this is 1.5 feet. Uh, so he cast one. So this one is given to 6 tall. This doesn't look good. So what it means is, mm, what I'm trying to say is, uh, 6 feet basically means quite this. So this is 6 feet. Okay, and this is, so basically the tree is quite, maybe this is the sun, and and the shadow is. But the reason I'm trying to do this is to show, because so this part like this. So this part is the shadow, which is 15. This is 15. So we'll try to, and the shadow of the person who is standing here next to the tree, this is 1.5. Okay, this is the person. It doesn't look good. Anyway, what I'm trying to say, we'll try to create a ratio of the shadow and how tall. These are the ratio we can think. So that means we can create a proportion. That means the person's shadow is given to be 1.5 feet. Okay, and then how tall is this? Is 6 feet. And this is about the person, but about the tree that you see here, the how tall is we don't know, but then we know the shadow is given to you 15 feet. Okay. So that means all you do is just cross multiply 15 both sides. So you multiply 15 both sides, and then this 15 crosses are and you get h equals 15 times 6 over 1.5. Now when I say there's a 15 and 1.5, I can multiply 10, 10 without calculator also we can do. So this will be 15 times 6 over 15. This will be 10 times 6 will be 60. And this 0 will shift the decimal one place to the right and get 15. And this 15 and this 15 cross out and get 6. So you get 60 feet height. So this is that h. So we needed to know what is the height of the tree, and you can see h is equal to there you go, and you're done. So this is how you have to set up the question, and I hope that helps. There are different ways. Some can do another strategy you could also use is watch this. You could also say the height of this one h. Okay. So you could use the height of how tall is the tree, and then how tall is the person. You can use this way also, and then you can think of the shadow. And the shadow is this, which is 15 divided by this 15, which is 1. And this also is correct. Okay? And you can work out and get the same answer. So in this case, you already given the nice figure to understand. So it's the same idea we can think of. So there are, one is a big triangle. So this is the height of the tree. So this is one triangle. So this is one triangle. Okay. And then there is another triangle which is formed by this person who is standing the red end. So the red triangle is this one. So what do we do here is this is 7.5 and this is 6 feet. How tall is this? 6 feet and the 7.5 is the shadow. But remember, we have to also be careful with, uh, oh, this one is the shadow of the tree. So we can use the, we'll use this way. So the other way around. Remember I said the height of the trees. So we'll use the height of tree divided by the person's height. Okay? And then we can think of the shadow of the height. Okay. So the height of the tree is we don't know. So it is x. So x divided by, and the height of the person is 6. So that goes down equal. The shadow is this piece, which is 107.5 feet, and the shadow of this is, of the person is, that is given to 7.5. So that's the shadow of the person standing there. So that's 7 point. You can use multiply both sides by 6. You multiply 6. And at this time, you can use a calculator and figure out the answer. So, and you can And that's how you do this type of problem. I hope I made sense understanding how to do this kind of problem.